one is black, this one is green, this one. So I have this dimension. Go for modeling environment. Now make this line from point from this point to apply. Generate concept lines from this point to this point. Apply. Generate line from this point to apply. Create one projection here. It allows point to generate go for the line body, assign the cross section. Object has been created here. Okay. Now close this design modeler. Go to modeling. And now the line bodies are there. First of all, check the line body. Like here, guys, whenever we are entering into the model environment and when we are doing the 1D analysis, so 1D analysis mostly will do the bending movements of the like beams, shafts, rods, or those things we are performing the 1D analysis. Okay. Now what we have to do is the first thing is we have to check whether the geometry is there or not. The geometry is properly there. I want the line body only. For bending moment now we require a path. Like what path or at what which path we have to find the bending moment. So for that reason what we have to do is first of all click on this model option and click the option construction geometry. We have to construct one path here. Okay, so it will create a construction geometry. So right click on this one, click on enter. Here you can find the option here path. Okay, so take that path. So it is asking me to specify the path here. So what I am doing here, see here we have two options are there, with points and with edges. So right now I don't have any points. If I take also it is not picking those points. So what I will do, I will go for the path option, or we can say edge option. For like edges or like edges only we have to take. So go for edges option and we have to select these edges. Control, select this one and the three edges you have to select, click on apply. Okay, now see here your path has been generated here. Now go for coordinate system to check whether it's there. Yeah, coordinate system also properly there. X-axis is this one, Y-axis is upside, Z-axis is here. So three axes are there. Now what you do, you have to generate the mesh. Relevance I am missing here. Sizing also I am making like fine mesh. Generate. Okay. mesh has been generated here. Yeah, the mesh has been generated here. Now to that mesh we have to assign the boundary condition. So right click, insert. What are the boundary conditions are there? Here we have fixed support, here we have simply support. Those two supports we have to specify. So right click, insert, fixed support, let me apply. Okay. Now the next thing is, here we have 50,000 newtons downward direction, 30,000 newtons downward direction, and here we have simply support. So right click, insert, take the simply supported here for this point. Apply. Now right click, we have to specify the force here. At this point, what is the force at that point? It is 50,000 newton in the y-axis downward direction. So go for component y-axis minus 50 kilonewtons means 50,000. Okay. Apply. Now at this point I have 50,000 newton force in the downward direction, and one more force we require here at this point. Apply in the downward direction, that is to be like 30,000 newton. Okay. Now the results we have to check here is shear force, we have to find, then bending moment we have to find, then we have to find here shear moment or bending moment diagram. Here we have to select the path, in which path we have to find. Okay, that's it. Now click on solve. Now see here, this is your bending moment diagram. See here guys, these things we have done in your academics also. Like in strength of material, these graphs you have created for bending moment diagram. Okay. Now see here, the first thing is total shear force we are getting here is 39,588. Total bending moment I am getting here is 4.7941 e to the power of 7. And here we have the bending moment diagram, how the body is deviating when you assign the forces. Okay. Below you have the displacement variations, how the displacement is varying here. Here you can find the bending moment diagram, and here you can find the shear force, how the force is distributed in here. Understand guys this one? Any doubts?
No, sir.
Understand this one, how to find the bending moment diagram? So like that we can see that. Here you can find the variations in the results. Total force is 7,000 like 50,000 and sorry 30 plus 40. So here you can find the table of data. If you go for report preview, here you can find the complete report of that. What are the inputs we have given, what are the outputs report. This is your you know, like if you like strength of material, guys, remember one thing, you have to be perfect in strength of material. Strength of material, thermal, and design of machine numbers. These subjects you have to be perfect. Any doubt in this one?
No, sir.
Okay, then fine. The next thing is find the maximum principal state and strain result on following beam model under universal distributing load condition. Now I am closing this one. I am going for the next analysis here. That is structural. Material it has mentioned like 2.132 to the power of 11. I want to calculate is 2.1 to the power of 11. Poisson's ratio 0.33. Okay, the two things are there. Close this one. Go for model. So here we have to create that model. What is the model? Like this is also 1D problem only. I section is there, and this is 9. The length is 150, 150, 150. Okay. So going with the same thing only. So suppose change the unit system to millimeter, and this plane I am creating the sketch. Go for line. Go to dimensions. So the dimensions are there here. 150, 150, 150. Generate. Drafting. Go for concept. Line from 2 times. Apply. Generate. Concept line from time. Apply. Generate. Concept line from time. Apply. Now I have the line body. Okay. Require one cross-section. Cross-section is mentioned here as I section. So go for concept cross-section to the I section here. This distance. This distance is mentioned as bottom side distance 15 mm. Okay. Then WT Heat is also like 15 mm. The next one is W3. W3 is mentioned as 26 mm. Then thickness 1 is 337. That is my cross section. Click on generate, go for line body, take the cross section or phi section, generate, view, it is your turn. Okay, you will close this one. Go for the model environment. Now the body has been created here. Now we have to check whether it's properly done or not. Yeah, it's okay. Check the line body geometry. Here we have coefficient. What are the results we have to find here? Like principal stress, strain, and we can find that thing also, like what is the bending moment diagram. Okay. The plot also created here. Go for generate now. The range should be here. First day. The mesh has been generated here. Now go for boundary condition or the boundary conditions are there. Here we have fixed, here we have simply supported. Those two things we have to specify. Insert, simply support. Here I am. Simply support. At that point. Okay. Now we have, see here we have UDL. Okay. Now how to assign this thing? Is there anything is there by giving a name like UDL? Let's check once. Insert. We don't have anything which represent UDL, means uniformly distributed load. If you go for force, means it will assign only a particular point where you are specifying. Okay. In that case, if you want the uniform distributed load or uniformly varying load, anything. So in that case, what we have to do means we have to use this option. See here, what is the formula for pressure? What is the formula for pressure? Anyone? Unit of pressure, sorry, the formula for pressure is force on area. Means on a particular area how much force is applying, means it is distributing, the force is distributing on a particular area. The same thing here also it's happening here. When you carefully see here, the force applying on this particular area here, the same thing here also, like 10 Newton per mm square to 150 Newton per mm square. That pressure we have to specify, so go for insert pressure, line pressure we have to take, select this edge, apply downward direction, like z axis, that is how much, like two data is there, 10 Newton per mm square and 150 Newton per mm square. So here what we have to do means, two values we have to specify. The first one, see here you can find the tabular data. So right click, go for tabular data. Okay. If you go for tabular data in z axis direction, starting is how much it is assigning there, 10 Newton per mm. It is showing mm here. Okay, we have taken wrong. It is not the 1D analysis, it is 2D analysis actually. But because it has mentioned here mm square means area. Area means it requires a complete surface. Here it is showing mm only. So I have to take, we will take initially 10 only here, and maximum load it is assigning as 150 Newtons per mm square. Okay. Now we have specified the uniformly distributed load. Okay. Now what we have to find? We have to find the principal strain and principal stress. Right click, insert. We have to go for, here we cannot able to find this stress strain. Why? Because we are doing the 1D analysis now. That's the reason it will not come here. So what I will do, I will take normal shear moment diagram. What is that? So now the same analysis I will do for the 3D. Actually the problem is 3D only. Why? Because it mentioned like area there. Area also mentioned there, and it is asking you to find the stress and strain, means you have to go for 3D analysis only. Why? Because in 1D we cannot find what we can say, stress strain option is not there. This is your bending moment diagram. Like that we can able to find. Now what I am doing, one more time I am taking this analysis. Stack structural. Material I am taking like same only. Just I am changing the geometry. Go for I section. First to take the cross section here. Why? Because I require a 3D geometry. For that reason, directly I am going for I section here. Change the unit to millimeters. It's a big. W1 I am giving like 15, 15, 26, 15, 15, 26, 3, 3. So cross section related, go for modeling, go for extrude, this cross section, apply. What is the length of that one? That is 150, 150, 150, so 450 is the length. Okay. Then what we have to do means we have to split these spaces. So here I said already that we have to create the splits here. So what I will do, I am selecting this space, create the new sketch, look at, Now create two lines here. One line, second line. Okay. The distances will specify here. Then this line. Go for genre. From this line to this line. This is 150. Then from this point to this point. It is also 1. These two things we have to take here. Now go for modeling. Okay. Now go for tools, split faces. This face I want to split. Apply by points and edges. I am selecting from points by pressing Control this point to this point. Apply. Okay. Now what happened here? It has been split. This is separate face and this is separate face. Here also we want to make one more split here. So go for tool, split space, face split, select this space, apply, select this by pressing Control, select this point to this point, apply, generate. Now see here these things are become separate faces. Okay, these three are separate faces now. Now close this design modeler. Go for the mechanical environment. Now see here guys, we have to check the geometry, then coordinate system, generate the mesh, make convert fine mesh here, update. The mesh has been generated here. Now we have to specify the boundary conditions. At this location it is fixed support. Here we have the simply supported. Go for fixed support. At this edge. Okay. Here we want simply support. See here guys, for 3D geometry we cannot say that one as a simply support. We don't have any option like a simply support area. So what we have to do, we have to go for the option insert displacement. So displacement means any one direction we can displace your object. So go for displacement and object like this side I want to make simply support. Where it should not move in the downward direction, means y-axis. So y-axis you have to make like 0. there should not be any displacement in y-axis. Remaining the x-axis and z-axis you want to keep free. Why? Because this is simply supported, means from the downward side I am making as a simply supported. Okay, from downward side it should not move. In a vertical direction it should not move. The remaining it can move in a horizontal line, like x-axis and z-axis direction it can move. So that's the reason I make this one as a simply support like that. In that way we can make. Now here, here we have the pressure on this face. Apply. I want in the downward direction. Yeah, anyhow it is in a downward direction only, so we can go for normal to the base. How much I want? I want the tabular data. Initial pressure I am giving like how much? 10 Newton per mm square. Maximum I am giving like 150 Newton per mm square. Now the results we have to find here is maximum principal stress and maximum principal strain. Maximum principal strain. Then we have to find the total deformation. And we have to find the equivalent one basis stress. Click on solve. Now see here guys, the problem gets solved here. Thing is, we are getting the maximum principal stress as 24,812 megapascal. Why? Because we specify the value very bigger that one. What I will do, I will change the pressure to unit system to metric pascal. This is like 10 and this is like 150 pascals. Okay, now get solved. Initially the value which I entered, that is a megapascal, that is a very big value. Now I change to somewhat smaller value which the problem has mentioned there, that is 10 Newton per mm square and 150 Newton per mm square. Now see here, check the maximum principal stress we are getting as 24,812 pascal. If I check this one into megapascal, it is like very less. If you go for PSI, it is like 3.5987 PSI. But I want in pascal only, that is 24,812 pascal is the maximum principal stress. Then maximum principal strain I am getting here as 1.2408 e to the power of -7. Total deformation I am getting here as very negligible deformation I am getting here, that is my 1.8665 into the power of -7, that is negligible. And equivalent stress I am getting here is 26465 pascal. If I change this one to megapascal, then we will get here 0.0265465 is the megapascal is the maximum stress is generating in that object. Okay, so like that you can able to find. Understand guys? Any doubts still here?
No sir.
No sir. No doubts?
No sir.
Okay, then fine.
No, sir.
Yeah. Okay, so guys, tomorrow is the last topic in static structure. Last class for static structure tomorrow. Okay, tomorrow I am closing the static structure. Whatever small things are like, whatever things are left there, I will explain you tomorrow. Okay, and then day after tomorrow we'll start the model analysis. Model analysis required only one day.